Dear student, in this video we will see the stoichiometry and limiting reagent. Initially, the chemical reaction that contain the reactant and the product. Okay, so for example, the A plus B gives C plus D. So this A and B as the reactant and this C and D as the product. So here the stoichiometry is nothing but the quantitative relation between the reactant and the product. Okay, so that is for the stoichiometry. So that means actually it's a quantitative relation between reactant and product. So that is for that stoichiometry. So this follows the simple the almost four types of the relation. For example, there is a weight of the reactant weight relation. Okay, weight of reactant and product, and there is a volume of reactant and product. This volume of reactant and product, this follows a liter unit as well as a ml unit. Okay, so liter unit as well as ml unit. The next, so then this liter unit and ml unit, and it depends on that number of molecules. Okay, number of molecule unit. So 1 2 3 and 4. So these four kind of relation simply explained in this video. Let we go to the equation of the methane combustion reaction. So methane, we know CH4 plus 2O2 gives, there is a carbon dioxide plus 2H2O. So here in this equation, methane has a how much molecules there? Only one molecule. So that's why this one, and here as a 2O2 molecule is there. So that's why here 2, and here carbon dioxide is 1 is there. So 1. Here water molecules has 2. So that's why here as representing 2. Okay. So then weight relation, here this methane of its molecular mass, CH4 actually carbon of mass as a 12, hydrogen here is a 4, so 12 plus 4, that is a 16 gram. Okay, so that's why I put on here, there's a 16 gram, and one O2 is a O2 here as 32 gram. So that's why here 2 O2, there is 64 gram of oxygen. And also this carbon dioxide, carbon as a 12, O2 as a 32, 12 plus 32 as a 44 gram. And this 1 mole of water as 18 gram, so 2 mole as a 36 gram. Okay, so this for that is simply saying the gram weight relation. And there is a volume relation. Suppose this methane molecule considered as a only one molecule, there is a only 1 mole. 1 mole of the gas is occupied as 22.4 liter volume, and this has a 2 mole of oxygen. So it's a double of its volume is presented in that oxygen molecule, because it's a 2 mole. So that's why here there's a 44.8 liter, and this carbon dioxide has a 22.4 liter, and similarly this water molecule has a 44.8 liter. Okay, so and also that ml, the liter is converted to ml, we can multiply by 1000. So that's why after that multiply of 1000, 22,400 ml, here 44,800 ml, and this carbon dioxide has a 22,400 ml, and water molecule as a 2 mole, that's why here 44,800 ml. So this all are, that is a simple relation, especially finding that stoichiometry. Okay, so whatever saying actual, the stoichiometry is nothing but the quantitative relation between the reactant and the product. Okay, so let's see this related one problem. It's related one problem. Now we will see. For example, the number of moles of sodium sulfate is produced from 1 mole of sodium hydroxide. Actually, the number of moles of sodium sulfate. Okay, the sodium sulfate is produced from 1 mole of sodium hydroxide. So actually the reaction, it's given in the question. For example, the 2 mole of sodium hydroxide plus H2SO4 gives Na2SO4 plus there is a H2O. Okay, so that's 2H2O. Here in this equation, the 2 mole of sodium hydroxide is needed as a 1 mole of H2SO4 is enough. But in the case of question, so we can written here, there is a 2 mole of sodium hydroxide is enough for 1 mole of H2SO4. So the 1 mole of sodium hydroxide, x mole, what, there is a half mole. Very good. So there is a cross multiplied, we can get in that there is x is equal to half mole, x equal to 1 by 2, there's nothing but x is equal to 0.5 mole. Okay, so that's why the 0.5 mole is enough in the formation of sodium sulfate from the 1 mole of sodium hydroxide. So similar, like a lot of question is asked. The question actually, the 10 gram of calcium carbonate, now how much volume of the carbon dioxide are produced. Okay, so in generally the calcium carbonate, that gives the calcium oxide plus carbon dioxide. So this is a 1 mole, okay, and this calcium oxide also is 1 mole. The carbon dioxide also is a 1 mole. So in generally the carbon dioxide as a gas. So we know that 1 mole of gases it occupied as 22.4 liter volume. Okay, okay. So this calcium carbonate 1 mole it occupied as a 22.4 liter. So there is a 22.4 liter or 1 mole of calcium carbonate gives there is a 22.4 liter. So the 10 gram of calcium carbonate, how much volume is occupied? That is the actual question. So the mole of calcium carbonate is needed. Mole of calcium carbonate that is equal to given weight divided by molecular weight. So actually the given weight that is a 10 gram. Okay. So the molecular weight of calcium carbonate has a 100 gram. So 0 zeros cancel out. There is nothing but 0.1. Okay. So 1 mole that is equal to 22.4 liter. So 0.1 mole of calcium carbonate, how much volume is occupied? Yes, 2.24 liter volume is occupied. So this is the answer. So here the answer is a 2.24 liter volume of carbon dioxide are produced in the 10 gram of calcium carbonate. Next is this question actually, what is the mass of carbon dioxide produced by heating 40 gram of 20% pure limestone? So the mass percentage that is equal to weight of element divided by molar mass into 100. So this calcium carbonate of mass is 100 gram. And also the percentage purity, okay, that's a purity percentage that is equal to here there is a weight of the pure compound. There's weight of the pure compound, weight of pure compound divided by there's a total weight. Okay, there's a total weight into 100. So this percentage purity here is 20 and the total weight what? It's a 40. We unknown this total purity weight of the pure compound into there is a 100. So we know we need to the x. So here x that is equal to this 20 into 40 divided by 100. So 0, 0, 0, zeros cancel out. We can get in that 8 gram. So the 8 gram of pure compound in 40 gram of total weight, that is a 20 percentage. Okay. So in generally in that concept, the calcium carbonate is undergoes decomposition reaction, calcium oxide plus carbon dioxide. So this calcium carbonate actually there is a 100 gram. So this 100 gram of calcium carbonate gives 44 gram of carbon dioxide. Okay. So the stoichiometric equation actually they are representing there's a 100 gram it gives there's a 44 gram of carbon dioxide. In the case of 8 gram, how much is produced? So interchange we can get in that x is equal to that is 44 into 8 divided by 100. So we can get in that answer 3.52 gram. So where that options are presented, see there is a yes, this first option is correct. The last video of the some basic concept of chemistry because we already given that video the concentration terms in that solution unit. Okay, this video of this topic is very last in the some basic concept of chemistry. So this limiting reagent is nothing but that is simply representing LR. This limiting reagent is nothing but the reactant which is completely consumed during the chemical reaction. Okay, so there is a reactant that is completely consumed, completely that is consumed in the reaction. Okay, consumed in the reaction. So whenever the reaction, the reactant, the completely consumed that reactant or act as a limiting reagent. Okay, so for example, the basic understand of here HCl as a 1 mole and 2 mole of sodium hydroxide. We can get how much mole of sodium chloride? Yes, there is a only 1 mole of the sodium chloride and the unreacted sodium hydroxide and there is a water molecule. So in this two as a reactant, here 1 mole of HCl and 2 mole of sodium hydroxide. For this reaction, the HCl has a very lesser amount. So that's why it's a totally consumed in the reaction, entire reaction. So that is why this acts as a limiting reagent. Okay, okay. So this is a very simple basic understand point of view I telling here. There is a HCl and 2 moles of sodium hydroxide gives a 1 mole of sodium chloride. Here as a limiting reagent as a HCl. Okay, so the formula is there. The limiting reagent that is equal to the given number of molecule or given number of given number of molecules, given number of molecules. Molecules, we know that amount of substances that is representing as a mole divided by there's a stoichiometry, that's a stoichiometry coefficient. Okay, stoichiometry coefficient. Okay, so this is very important for finding that limiting reagent. For example, the 40 gram of calcium carbonate is treated with there is a 40 gram of HCl. So which of the reactant will act as a limiting reagent? Here limiting reagent which is, so in general this equation the calcium carbonate plus HCl 2 mole gives there is a calcium chloride plus 2 mole of HCl 2 mole of H2O, sorry, there is a 1 mole of H2O plus carbon dioxide. Okay, so this is a general reaction. In this equation we finding that calcium carbonate mole as well as HCl mole. So there is a mole of calcium carbonate that is equal to actual formula given weight divided by molecular weight. Here given weight as a 40 gram, and the molecular weight of calcium carbonate here there is a 100 gram as a molecular weight. The HCl is a 36.5 gram as a HCl weight. Okay, these two is the molecular weight of HCl and calcium carbonate. Here is a 100, 0 zeros cancel out, we can get the 0.4 mole. And similarly, there is a mole of HCl. Mole of HCl here is a given weight as a 40 gram of HCl divided by 36.5. So it's a simplified this we can get in there is a 1.09 mole. So this find out that mole of calcium carbonate and HCl. After that, this mole we can divided by that it's a stoichiometry. For example, the 0.4 mole divided by calcium carbonate of its stoichiometry is a 1. So that is equal to 0.4. And similarly, the HCl of its a mole that is 1.09 divided by its a stoichiometry of HCl here as a 2. So this approximately that is equal to 0.5. So this 0.5, this is a 0.4. So that's why the sodium calcium carbonate it's a limiting reagent because it's a very lesser amount. So that's why it's act as a limiting reagent. Okay, so the calcium carbonate as a limiting reagent is act as a limiting reagent. So similar like the lot of questions they have asking in the NEET and JEE, especially NTA. Okay, I think you are well clear for this limiting reagent as well as the stoichiometry subtopic of some basic concept of chemistry. Once again, I will thank to all. If you like in this video, you can subscribe and share your friends. Thank you very much. Still, we completed that 3 unit. That unit or that is a solution and GOC and that some basic concept of chemistry. Let's we see that new unit. Okay, thank you everyone.